Good morning all. In this video, I'm going to discuss about linear integrated circuit and operational amplifier basics. Outline to be covered in today's video session. What is integrated circuits? Why integrated circuits and operational amplifier basics? What is an integrated circuit? The integrated circuit IC is a miniature low-cost electronic circuit, and it will be consisting of all the active and passive components that are joined on a single crystal chip of a silicon. And the active and passive components which we normally use for this IC are a transistor, resistors, and capacitors. And if you see, most of the components which are used in the IC are not going to be similar to the conventional component which has been present in appearance, but the electrical function of both will be similar. Why integrated circuit? This integrated circuit is going to offer a number of distinct advantages when compared by connecting a discrete components, and it is also be used for a wide range of application. Now let us see what is the advantage of an integrated circuit over by interconnecting a discrete component. The first advantage is large and complex circuits can be reduced by small size by using a IC technology. And second application is miniaturization and hence increased equipment density. And next is cost reduction. This is due to the batch processing. And next is increased system reliability can be achieved due to the elimination of solder joint in ICs. And next one will be improved functional performance, which is possible to fabricate even a complex circuit for better characteristic in a IC. And next advantage will be increased operating speed due to the absence of parasitic capacitance effect in IC. And next last one will be a reduction in power consumption. Now let us see a linear integrated circuit applications. This LIC linear integrated circuit is going to be used for a variety of electronic applications like audio and radio communications, medical electronic communications, electronics applications, instrumentation, control, and etc. on many applications. Here we are going to see a very important type of a linear integrated circuit, which is nothing but operational amplifier. An operational amplifier is nothing but it's a direct coupled high gain amplifier which will be consisting of one or more differential amplifier that is being followed by a level translator and output stage, and this is going to be the internal blocks we'll be having in this operational amplifier. And this op-amp can also use to amplify both AC as well as DC input signal. That is, we can apply AC as well as DC input as an input to this op-amp, and it will be designed in such a case that it is used for computing variety of mathematical functions like addition, subtraction, integration, differentiation, and can be used as an instrumentation amplifier for medical applications and industrial applications, and log and anti-log amplifier. And now let us see the op-amp circuit symbol. The first figure shows the op-amp circuit symbol. Here we're going to see the special type of operational amplifier, which is nothing but 741. This op-amp consists of two input terminals and one output terminal, where the negative sign indicates the inverting input terminal, which is nothing but terminal number 2, and the positive sign indicates a non-inverting input terminal, which is the terminal number 3, and the output terminal will be the sixth pin, and the seventh pin, the positive of the external DC source will be connected into the fourth pin of this op-amp. The negative of the DC supply voltage will be connected. These two supply voltages will be connected to the op-amp to make the transistor and the op-amp to be operated in an active region. The right side, the diagram shows pin diagram of a op-amp 741. Here it shows a 8-pin IC. The first pin of this 741 op-amp is a offset null pin. Second pin is the inverting input, and third pin will be a non-inverting input. And the negative of the supply source will be connected to the fourth pin. Fifth pin will be offset null. Sixth pin will be the output terminal, and seventh pin, the positive of the DC source will be connected, and eighth pin, no connection. Now let us see famous IC packages available. Three packages are available. Metal can package, we normally call this one as TO package, a dual inline package, and flat package or flat pack. Okay, the left side, the diagram shows op-amp IC packages. The first one is a TO5 style package, which is nothing but a metal can package, which has been available in a 8-pin IC for. And second one will be dual inline, which we normally call as a DIP package. So we are going to study about this one, that is 8-pin mini DIP. That is nothing but mu A741 IC. And the pin diagram of this we have already seen the previous slide. And the next one will be this DIP package will also be available in a 14-pin DIP package, but the pin diagram of a 14-pin will be somewhat different when compared to your 8-pin DIP package. Here in the 14-pin DIP package, the first and second terminal no connection. Third terminal will be offset nil. Then the inverting non-inverting terminals of the op-amp will be fourth pin and fifth pin. Sixth pin, the negative of the supply will be connected, and seventh pin is no connection. Eighth pin no connections, and your ninth pin will be offset null, and 10th pin we are going to take the output. 11th pin positive of the supply will be connected, and the remaining will be no connections. And the last picture shows the a flat package of a IC. Here it shows a 10 pin flat package IC and its pin diagram. Now let us see what is the supply we can apply for the op-amp to be operated in active region. See here the circuit shows a schematic symbol with the two input terminals and the output sixth pin, and seventh pin and fourth pin the supply DC supply will be connected. Here V plus, which is nothing but seventh pin, the positive of the supply will be connected to the positive of the DC source, and the negative will be grounded. And for the fourth pin, the negative of the supply will be connected and the positive will be grounded. And the op-amp 741 supply voltages will be ranging from 5 volt to 22 volt, which can be operated. But for the practical applications, we normally use a supply volt range of plus or minus 15 volt and plus minus 12 volts will be used. And next we'll see about the manufacturer designation for this linear ICs. There are different manufacturers are being used to manufacture this linear IC. The Fairchild, and each manufacturers will be using their specific code and number to specify each ICs. Your Fairchild, they are going to use a specific code of mu A and mu AF, and National Semiconductor will use a specific code for the IC as LM, LH, LF or TBA, and the Texas Instruments are going to use SN, and Signetics are going to use NS or NE or SE, and few more manufacturers like Motorola, they are going to use a specific code as MC. So each manufacturer's specific code will be different, but all the manufacturers are going to use a common IC number for this operational amplifier integrator circuit. So the IC Fairchild is going to use a MUA741, and National Semiconductor they use the IC number as LM741. So LM is a specific code used by the manufacturers, and if you take a Signetics, they are going to use a NE or SE. Followed by that, we'll be having a IC number. So in this video, we have seen about the basics of operational amplifier and what is the power supply range it can be operated. The reference book for this is a linear integrated circuit by Rai Chaudhary and Selby Jain. And we'll discuss about the ideal characteristic of an operational amplifier in our next video session. Thank you.